Today's video, what we're going to be doing is looking at some more stoichiometry problems, and with two of these problems we're going to look at today, we're going to have a volume of a liquid. This is going to help you out with examples like problem number 2 and some other problems later on that you're going to kind of see. So our first example, how many liters of carbon dioxide can be produced when 75 milliliters of pentane, C5H12, reacts with an excess of oxygen? One piece of information that we're going to be given with these types of problems is we're going to have the density of our liquid. So the density of pentane is 0.626 grams per milliliter. Let's go ahead and mark what our known and unknown are. How many liters of carbon dioxide? So since we're trying to look for information about carbon dioxide, CO2 is our unknown. Can be produced when 75 milliliters of pentane. So since we have some information about pentane, that's going to make it our known. Now with this, we're going to have one extra step that we're going to have to do at the beginning. We still follow along with our flow chart that we had down in our notes in the first video. We still start with the amount of known. And this time around, it's just a volume of a liquid. Okay. So we still start 75 milliliters of pentane. Now what we're going to do extra is we're going to convert our volume to grams, and the way that we're going to do that is we're going to use our density. So we take our volume times our density, the volume gets canceled out, and we're left with grams. So this would start us off with grams of our known. So the next step in the process is go to moles of known. So 1 mole of pentane, C5H12 over, and we need to figure out what is the molar mass of pentane. 5 times 12.1 plus 12 times 1.01. And I'm coming up with a mass of 72.17 grams. That would cancel out grams there. And then we go to moles of unknown, which we're supposed to use our coefficients, which we didn't balance the reaction at first, so let's go back and do that real quickly. 5 carbons on the left, 1 on the right, so I'm going to put a coefficient of 5 right there in front of carbon dioxide. Go to hydrogens, 12 hydrogens on the left, 2 on the right, so I'm going to put a coefficient of 6, get 12. Oxygens, we have 2 on the left, 5 times 2 is 10, plus 6 more, 16, so to get 16 on the left hand side, I'm going to put a coefficient of 8. So our mole to mole ratio, unknown over known, we have coefficient of 5 in front of our unknown, so 5 moles carbon dioxide, 2, and we have coefficient of 1, or understood 1 in front of our known, so 1 mole of C5H12. Moles of pentane get canceled out. Then our last step, since we're trying to figure out how many liters of carbon dioxide, and carbon dioxide is a gas, we're going to have 22.4 liters CO2 up in the numerator in our last ratio over 1 mole CO2. Moles of carbon dioxide get canceled out. So here's our setup. Now, putting this into our calculator, I'm going to take 75 times 0.626 times 5 times 22.4. That's all divided by 72.17. I'm coming up with an answer of 72.86 liters carbon dioxide. Let's look at another example of this type of problem. How many grams of phosphorus tribromide could be produced when 250.50 milliliters of bromine reacts with phosphorus? Once again, we're given the density of our liquid. Density of bromine is 3.10 grams per milliliter. Let's go ahead and mark our known and unknown. So how many grams of phosphorus tribromide? That would be PBr3. Could be produced when 200.50 milliliters of bromine. There's our known. Now let's balance this. 1 phosphorus, 2 bromine, 3 bromine. So the least common multiple between 2 and 3 is 6. So I need a coefficient of 3 in front of bromine on the left-hand side and coefficient 2 in front of PBr3 to give us 6 bromines on both sides. Now with this coefficient of 2, this tells us that we now have 2 phosphorus on the right-hand side. Need a coefficient of 2 in front of phosphorus on the left-hand side. Okay, we're going to start with the amount of our known, so 200.50 milliliters of bromine. And then once again, like what we did up here, we're going to take our volume and multiply by the density. Volume multiply by density. 3.10 grams per milliliter. Volume of our known gets canceled out. Now we're in grams of known. Now the next step is we're going to go 2 moles of known. So 1 mole of bromine. 79.90 times 2. Come up with 159.80 grams of bromine. So grams gets canceled out. Next step is moles of unknown. So our mole ratio in this one, we have 2 moles PBr3 over 3 moles Br2. Moles of bromine get canceled out. Then our last step, since we are trying to find grams of our unknown, we need to find what is the molar mass of PBr3. So phosphorus is 3.97 plus 3 times 79.90. So I'm coming up with 270.67 grams PBr3 over 1 mole PBr3. So moles PBr3 gets canceled out. 200.50 times 3.10 times 2 times 270.67 divided by 159.80 times 3. And I'm coming up with the answer of 701.86 grams PBr3. Okay, so these two problems, this will help you with problem number 2 on the assignment. Now, we don't always have to go from start with the amount of our known. Sometimes we can start with moles of our known, or we can go to moles of our unknown. So to kind of show you an example of this problem, if we look at this example, it says what mass in grams of aluminum hydroxide could be produced when 8.25 moles of sodium hydroxide react with aluminum nitrate. What mass in grams of aluminum hydroxide? So aluminum hydroxide is going to be our unknown. And we have 8.25 moles of sodium hydroxide. A lot of the times our unknown is going to be our reactants, and our known is going to be our unknown is going to be our products, excuse me, and our known are going to be the reactants. But we can also flip that around and have a problem in which the known will be one of your products and the unknown will be one of the reactants. All right, so we have our known unknown mark. Let's balance it. 1 sodium, 1 sodium, 1 hydroxide, because hydroxide is OH. On the right hand side we have 3 hydroxides, because OH inside, parentheses, and 3 on the outside. So I'm going to put a coefficient of 3 in front of sodium hydroxide. Now that's going to give us 3 sodiums on the left hand side. We need 3 sodiums on the right, so I'm going to put a coefficient of 3 in front of sodium nitrate to balance that out. Now aluminum, we have 1 on the left and we have 1 on the right. Good to go there. Now we have 3 nitrates on the left hand side, and since we put this coefficient of 3 in front of sodium nitrate, we have 3 nitrates on the right hand side. Let's go ahead and start working. Now the piece of information of our known, we have 8.25 moles of sodium hydroxide. So if you look at that flow chart, we're not starting with the amount of known, we're starting with moles of known. And we just keep on going through the flow chart. So from moles of known, we go to moles of unknown. Well, looking at our coefficients from our balance reaction, unknown over known, so we have 1 to 3 ratio, so 1 mole aluminum hydroxide to 3 moles sodium hydroxide. Moles of sodium hydroxide get canceled out. Then our last step is to go to the amount of unknown, and we're trying to find the mass in grams, so we need to figure out what is the formula mass of aluminum hydroxide. Well, we have 1 aluminum, mass of aluminum 26.98, plus we have 3 oxygens, 3 times 16, plus 3 hydrogens, 3 times 1.01. Now I'm coming up with a mass of 78.01 grams. And that'll be over 1 mole. And that's our setup. 8.25 times 78.01 divided by 3. I'm coming up with an answer of 214.53 grams aluminum hydroxide. Alright, so this should help you out a little bit more with the assignment for this week. If you have any questions, please email me, and I will talk to you later. Thank you.